Okay, now for the sixth part, what you are going to study is you are going to start with refraction from curved surface. Okay, so let us study refraction from curved surface. So what do I mean by this? See, up till now, whatever I was studying, like there was some plane kind of thing, no? There was some plane surface, under was water, and above was air. And we applied Snell's law, sine, okay? But now what our case is going to be is, instead of these cases, say suppose air is there, and in this side, on the right hand side, the entire medium is made up of glass, okay? This is our axis, okay? Now when an object is out here, where in the glass is the image formed, that you are going to study in the subject of refraction through curved surface. That means this entire medium is made up of glass, and this ray out here, a ray from the object would go and form an image, okay? See, out here, what is the formula that is governing the image distance and object distance, where object distance is nothing but measured from this is nothing but the object distance, and this is nothing but the image distance, okay? While taking object distance and image distance, similarly like mirror, we follow a sign convention where either of the side is positive and the remaining side is negative, okay? So my question is, what is the formula that is governing this refraction, or what is the relation between u and v? The relation between u and v can be given by, this is the refractive index of air and this is the refractive index of glass, okay? The relation between u and v can be given by, see, what is the medium that contains the object? Mu of A, or air contains the object, divided by, acha, I wrote a little bit wrong, okay? We start with image. What is the medium that contains the image? The glass contains the image. So refractive index of glass divided by distance of image from the hole or from the surface, minus refractive index of air divided by object distance, because object is kept in A, is equals to refractive index of glass minus refractive index of air divided by radius of curvature of the mirror. Radius of curvature means this surface has a radius of curvature, no? And I'm interested about the radius of curvature of this surface. The radius of curvature is the radius of this surface, where r is the radius of curvature, where out here v is equals to image distance from the surface, from the surface. U is equals to object distance from the surface, object distance from the surface. Mu g, acha, can I replace mu g with mu of r? Why? Because mu of r is nothing but medium containing the refracted ray. Refractive index of medium containing the refracted ray, containing the refracted ray, refracted ray. So out here mu g was being replaced by mu r. Okay, similarly, let's replace mu a by mu I. What is mu I? Refractive index of medium containing the incident ray. Refractive index of medium containing the incident ray. And what is R? R is nothing but the radius of curvature of the surface. Radius of curvature of the surface. Now I have few questions. What happens if this surface is not spherical? If the surface is not spherical, there will be multiple number of images for the same object, and that will be done in, or that will be dealt later. So this formula, okay, is only valid when the surface separating the two is spherical. Okay, and while using this formula, make sure to take sign convention out here. That means out here R would be taken as positive because this sign is assigned as positive. Object distance would be taken as negative, and image distance should be taken as positive, or the formula would give the image distance as positive. Okay, similar like mechanics. Now what you are considered about is magnification due to a curved surface. Magnification due to a curved surface. Okay, so out here there was an object, out here there was an image. This is the object, this is the image. Okay. Okay, out here this is the radius of curvature. Now suppose I have a object which has a height ho, and I have an image which has a height hi. Magnification is nothing but, when I say magnification, or vertical magnification is nothing but represented by name, which is equals to height of image by height of object is equals to v by u. But in case of curved surface, it is mu I by mu r. See, note something out here. In case of curved surface, it is same as in case of mirror. So minus v by u is same as mirror. But out here, mu I is the diffractive index of medium containing incident ray. So mu I is somewhat related to u, and mu r is the diffractive index of medium containing the refracted ray. So out here mu r is somewhat related to the v. So out here it becomes little bit opposite. Okay, which can be used as velocity of image by velocity of object, or vertical velocity of image, vertical component of velocity of image by vertical component of velocity of object, and vertical component of velocity of image. This vi is vertical component. Okay, now what you are considered about is axial magnification. Axial magnification. Okay, what is axial magnification? Axial magnification is nothing but thickness of image by thickness of object. So suppose this object was this much distance. Okay, let this be represented by to. Okay, and this image was this much distance. Let this image be represented by ti. Okay, now my question is, what is the relation between thickness of image and thickness of object? Okay, see, can I say this ti to be dv? Okay, and this thickness of object to be du. Okay. So if I write the formula through a curved surface, can I say mu r by v minus mu I by u is equals to mu r minus mu I divided by r? If I differentiate the term with respect to the respective components, so mu r minus by v square into dv minus of minus mu I by u square into du. What I am doing? I am doing or differentiating this entire term with respect to dv, this entire term with respect to du, and I'm then again multiplying this entire term with respect to dv, and again multiplying this entire term with respect to du. Okay, okay, is equals to this entire term mu r minus mu I by r is a constant, so differentiation of any constant is equals to 0, so we get is equals to 0. If we solve this one, for minus mu r by v square dv plus mu I by u square du is equals to 0. Okay, or mu r, oh, sorry, or mu I by u square du is equals to mu r by v square dv. Okay, or dv by du, or mu I by mu r into v square by u square is equals to dv by du. And dv is what? Dv is nothing but thickness of object. See, dv is nothing but thickness of object, and du is nothing but thickness of, sorry, dv is nothing but thickness of image, and du is nothing but thickness of object, is equals to dv by du, thickness of image divided by thickness of object, and this is nothing but the magnification, or is equals to mu I by mu r into v square by u square. So even remember out here, see, even v square by u square is same as mirror, but out here mu I is related to object and mu r is related to image. Okay, now the relation between velocity of image or axial velocity of image is to axial velocity of object is equals to axial velocity of image by axial velocity of object, or axial velocity of object in this side, axial velocity of image in this side. Okay, okay. Now you must observe one thing, that a curved surface, the formula for curved surface can be applied in the case of formula for plane surface also. Okay, so just make your observation out here. Okay, what is the observation? A plane surface behaves as a rush surface when, sorry, a plane surface behaves as a curved surface when radius of curvature is equals to infinity. That means out here, a plane surface behaves as a curved surface, behaves as a curved surface when radius of curvature, when radius of curvature is infinity. That means out here there is a air, and the medium separating the air and glass is, so out here also, if I draw a straight line, the radius of this glass surface interface is infinity. So out here, if there is an object with object distance u, okay, the image distance, out there is an image with image distance v. The relation between object distance and image distance would be given by mu of r by v minus mu of I by u is equals to mu of r minus mu of I divided by r. This r goes to infinity in case of plane surface. or this entire term, if r goes to infinity, this entire term becomes 0. So can I say mu r by v minus mu I by u is equals to 0, or mu r by v is equals to mu I by u, or v by u, or v by u is equals to mu r by mu I. Okay, or object distance by image distance out here becomes mu r by mu I. Okay, so taking the same concept as studied before, what we study now is concept of apparent depth and real depth. Concept of apparent depth and real depth. What is concept of apparent depth and real depth? Suppose this is a swimming pool, and this swimming pool is filled with water with refractive index mu w, and out here there is air with refractive index mu a. Suppose a person is just standing on the swimming pool. See, the leg of the person, or the incident ray from the leg of the person, would come out here. Suppose there is an observer out here at the side of the swimming pool. Okay, there is an observer. Okay, the observer would see the height of the person as this much, h dash, but the actual height of the swimmer is total h. Okay, where h is the real height, where h is the real height, and h dash is the apparent height. Apparent meaning perceived height, or height as seen by the observer out here. Apparent, ENT I think. Apparent height. Now what is the formula for apparent height by real height? Apparent height is nothing but the height of object. Real height is nothing but the height of image. Okay, and what is the formula for height of object divided by height of image? So I can say that from the previous section I have derived a formula: v by u for plane surface is equals to mu r by mu I. Okay, or what is v out here? V is nothing but h dash, or apparent height, or height as observed by the viewer, divided by h. H is the actual height of the object, or object distance. Okay, is equals to mu r. What is mu r? Ray containing, or medium containing refracted ray, or mu of air divided by mu of water. Okay, incident ray is mu of water. So out here can I say apparent height by real height is equals to mu a by mu w. Okay, now this is for a case when the person is underwater. Now what happens in a case when suppose a bird is flying out here? Suppose there is a bird, or there is a plane flying out here. Okay, and a fish is underwater. Okay, or a submarine is underwater that is observing the plane. Okay, now see, the incident ray from the plane would come out here. Okay, out here. Now due to the change in water with mu w and air with mu a. Okay, this is air, this is water with mu w and air with mu a. Okay, now due to the change in medium, when the ray is traveling from lighter medium to denser medium, the refracted ray would bend towards the normal. Okay, and go out here. But according to the submariner, where is the aeroplane appearing at? The aeroplane will appear at this height, no? This height. Okay, the aeroplane will appear at this height, but the actual height of aeroplane is out here. Okay, so let this height be h, or actual height of the aeroplane, and let this height be h dash, or the apparent height of the aeroplane, or observed height by the aeroplane. So from here, can I apply the formula that I have added before? V by u is equals to mu r by mu I. Okay, out here image is nothing but the apparent height, okay, divided by real height, is equals to mu, or refractive index, medium content in refracted ray, that is nothing but mu of water divided by mu of air. So this is our formula when the ray travels from denser medium to rarer medium, or when the observer is at rarer medium, this is when the when the observer is at denser medium, this is when the observer is at rarer medium. The observer out here, the observer is at dense out here the observer is at denser medium, out here the observer is at rarer medium. Okay, and out here the rays goes from denser to rarer, out here the rays goes from rarer to denser.
Acha. Now we'll study of shift through a glass slab. Okay, we'll study about shift through a glass slab. Through a glass slab. So what exactly are we going to study out here? See, suppose there is a glass slab out here. The thickness of the glass slab is T. Okay, now there is a point object out here. The point object is out here. Okay, now this point object and the observer is somewhere around here. Okay, my question is, what is the, if this is the object, where will this observer see this object? Okay, so how do I do? I take a straight line. This is one of the arrow that gets undivided through the glass slab. Another arrow goes somewhat in this manner. Let me just okay, our glass guy, or eyes of our glass guy, is actually out here. Okay, so he actually sees the image out here, no? So if this is the object, this is the image of the glass slab, sorry, this is the image of the object, and this entire length is called shift, or shift by which the image is shifted from the object. And the formula for shift is, shift for a glass slab of thickness T is given by T into 1 minus 1 by mu, where mu is nothing but the refractive index of the glass divided by refractive index of air, or refractive index of surrounding medium. Okay, now my question is, how do I derive this thing, or derivation of shift through glass? Derivation. Okay, so in earlier topics, or in earlier slides, we learned that, okay, the refraction through a glass surface, or refraction through a plane surface, okay, is given by mu r by v minus mu I by u is equals to 0. Okay, or you know the formula that mu r by v minus mu I by u is equals to 0 for plane surface, or v by u is equals to mu r by mu I. This is the formula for plane surface, diffraction through surface. Now see the surface out here. In ray optics, okay, whenever there are multiple devices, or multiple mirrors, or multiple lenses, the concept out here is the image of the first device acts as an object for the second device. So concept out here. in multiple mirror or lens or surface system, the image of the first device, that means mirror lens or surface, acts as the object for the second surface device or mirror or lenses. Surface, mirror, surface or lenses. Mirror, surface or lenses. This is our underlying concept. That means the object of this surface would act, sorry, the image of this surface would act as an object for this surface. Okay. So out here there are how many surfaces are there? There are two surfaces out here, first surface and second surface. Okay. So image formed by this surface would act as an image or object by this surface. This much we know. Okay. Now let's follow the incident ray. The incident ray is going like this, Okay. So for incident ray to go like this is the first surface, this much cross. So for surface 1, okay, we apply this formula. V by U is equals to mu R by mu I, or V by U is equals to mu R by mu I. See out here. Out here, mu R is nothing but the refracted ray, and refracted ray medium is in glass. So mu R is nothing but mu. Mu R is nothing but mu. Mu I is nothing but medium containing incident ray. So incident ray is in here. So mu I is equals to 1. Now height of image. Height of image is C out here. As I am crossing this surface, our first observer, or our observer would be out here, no? And for this observer, where is the image formed? The image would be formed somewhere around here, no? This is the image due to first surface. Okay, so image due to first surface. Let us delete this shift for a little while. Okay, you all make a new diagram. Okay, so let us tell the position of this image as age 1. Okay, and let the object distance be u. Okay, so object distance is nothing but u, and image distance is nothing but h1. h1. So can I say h1 is equals to mu into object distance? Okay. Now for second surface. So after first surface, this row goes out here and goes out here. So for an observer out here, the image is formed out here. Now this image will act as an object for this surface, no? Okay, this incident ray has to cross this surface. So out here, for this surface, the observer will be out here, and the object or the object position would be for this, and this image would act as an object for this surface. Understood this one? Okay, the image of the first acts as an object for the second. So this, for this surface, this is our object. Okay, so for surface 2, we apply the same formula. V by U is equals to mu R by mu I. But out here you have to be careful. Why? See, mu R is nothing but refracted ray. So refracted ray is 1. So okay, refracted ray is 1. Similarly, incident ray is out here. So it is mu, or incident ray is mu. But for V and U out here, U changes a bit. How? this is the object for the second surface, I know that, but this object or the length of the object should be calculated from this surface, so the distance of the object is nothing but t plus h1. Distance of the object is t plus h1, not only h1. Okay, h1 was the distance from this surface. We have to calculate the object from this surface, so t plus h1 is equals to t plus h1, and this image v is equals to, it is the position where the image is formed. So can I say v is equals to t plus h1 by mu? Okay, now shift. What is shift? Shift is nothing but final position image minus initial object image. So this distance is called shift. Okay, this v is nothing but this much distance from image to this surface. Okay, and shift is nothing but final image minus initial object. So this distance is called shift. So can I say shift is equals to u plus t. That means I have to calculate the position of object from out here, no? So u plus t minus the position of image. Position of image is how much? T plus h1 by mu, or t plus h1 by mu. Or you can simply say that shift is equals to u plus t minus t by u minus h1 by u. And what is the value of h1? The value of h1 is nothing but mu into u. The value of h1 is nothing but mu into u. Okay. So if mu and mu would get cancelled, our formula for shift would be shift is equals to how much? U plus t minus t by mu minus u, or u plus u and minus u would get cancelled, or shift is equals to t into 1 minus 1 by mu. And this is the formula for shift for a rectangular slab. Acha, now make a note out here. See, the formula for shift is independent of the position of the object from the glass slab. Okay, shift is only dependent upon the thickness of the glass slab. So more of a observation, not a note. Observation. Shift is independent of the object distance from the glass slab. Okay, it only depends upon the thickness of the slab. Depends upon the thickness of the slab, and relative refractive index of the slab. Okay, relative refractive index of the slab. Now what you're going to study is about shift through multiple glass slabs. That means our next topic is shift through multiple glass slab. What we are going to study out here is, suppose there is one glass slab out here, somewhat like this, okay, of thickness T1, and refractive index mu1. There is another glass slab kept on top of this, thickness T2 and refractive index mu2. There is another glass slab kept out here, thickness T3 and refractive index mu3. Suppose there is an object out here. Okay. Now how much is the final image shifted by, or image as seen by the observer? Okay, out here, shifted by. This distance is total shift. Total shift. Okay. So the formula for total shift due to multiple glass slab is equals to shift due to glass slab 1 plus shift due to glass slab 2 plus shift due to glass slab 3. That means the total shift is the sum of individual shift. Glass slab 1 plus glass slab 2 plus glass slab 3. What is the shift due to glass slab 1? Due to glass slab 1. So T shift due to glass slab 1 is T1 1 minus 1 by mu1. Okay. Shift due to glass slab 2, T2 1 minus 1 by mu2. T3 into 1 minus 1 by mu3. Okay, so total shift is equals to summation of individual shift of each of the glass surfaces. Okay, let's do this question. A point source of light is placed 4 meters below the surface of water. That means out here, this is water surface. 4 meters below the water surface, a point source of light is kept. This is 4 meters below the water surface. Okay. The refractive index of water is given by mu is equals to 5 by 3. The minimum diameter of a disc which should be placed over the source on the surface of water to cut off all the light coming out. That means what the question is telling is that this source of water or this source of light, point source of light, after a certain angle, this will perform total internal reflection. So no light comes out from this area, no? So what is the total light coming out from this area? Okay, out here, this is the angle and this is the value of total internal reflection. Okay. This is nothing but theta c. Sorry, I made a mistake. Okay, if I draw a normal out here, this is nothing but critical angle. Even this is critical angle. Okay, so this is now her radius of circle out here, or this is the height. Okay, can I say mu of water across this surface? The mu of air is given as 1. So across that surface, can I apply Snell's law? Or mu of water into sine of critical angle is equals to mu of air into sine 90. Mu of air is 1, sine 90 is 1. Okay, and mu of water is given as 5 by 3 in the question itself. Sine theta c is equals to 1, or sine theta c is equals to 3 by 5. Okay, so out here, sine theta c, this theta c which is equals to this theta c is equals to 3 by 5. So sine theta c is nothing but perpendicular by hypotenuse is 3 by 5. Okay, now see, this distance is 3, this distance is 5, and this distance is 4. So 3 square plus 4 square, 3 square plus 4 square is equals to 5 square. So our correct radius is 3. Out here, fortunately, the ratio of 3 by 5 coincides with out here 4. Okay, so our correct answer is the diameter of this. They have asked the diameter of this. What I have done is the radius of this, the minimum diameter of the disc. If the radius of the disc is 3, the diameter of the disc should be 6. So don't perform this kind of silly mistakes. So if this much is 3, this entire length should be 6 meters. Okay. 6 meters should be entirely. Okay. Acha. Let's read the question. Electromagnetic radiation of frequency mu, velocity v, and wavelength lambda in air enters a glass slab of refractive index mu. The frequency, wavelength, and velocity of light in the glass slab will be respected. Whenever we change the medium or whenever refraction occurs, okay, the velocity of light changes, velocity changes, frequency of light remains same, remains same, and wavelength of light also changes. Okay, so whenever refraction occurs, wavelength of light and velocity of light changes, whereas frequency of light remains same. Okay, so the correct option is option number C. Acha, we have just learned that while refraction, okay, the wavelength of light changes, the velocity of light changes, but the frequency of light remains same. The frequency of a light wave in a material is given by 2 into 10 to the power 4 Hz, and wavelength is given by 5000 Armstrong. The refractive index of the material would be. See, before solving this question, you must know a formula. Velocity of light in any object. Velocity of light is equals to, or velocity of wave is equals to frequency into wavelength. Okay, out here frequency is given by 2 into 10 to the power 14 Hertz. Hertz is the SI unit of frequency. Wavelength is given by 5000 Armstrong, and this Armstrong has been converted to meter. So if you multiply Armstrong by 10 to the power minus 10, it gets converted into meter. Okay, because 1 Armstrong is equals to 10 to the power minus 10 meter. So 5000 Armstrong should be equals to 5000 into 10 to the power minus 10 meter. So out here we get speed of light is equals to 2 into 10 to the power 14 into 5 into 10 to the power 3 into 10 to the power minus 10. So 5000 into 10 to the power minus 10. So it would be 2 into 10 to the power 4. Acha. Or C would be 10. How much would be C? 5 2 is 10, 10 to the power 4, 5 6 7, or 10 to the power 8 meter per second. Okay. The speed of light in that medium, would be 10 to the power 8 in meter per second. So refractive index is nothing but speed of light in vacuum. Speed of light in vacuum is nothing but 3 into 10 to the power 8 meter per second by speed of light in that medium, which should be equals to 10 to the power 8 meter per second. 10 to the power 8 meter per second. This and this would get cancelled, or mu should be equals to 3. Okay. Let's look at this question. A small coin is resting on the bottom of a beaker filled with a liquid. A ray of light coming from the coin travels up to the surface of liquid and moves along its surface. See the figure. How fast is the light traveling in the liquid? So what they're asking is that a ray of light comes here and travels along the surface. So this is nothing but the critical angle. No? So if I draw normal out here, this is 90 degree, and this mu is how much? I have to find it out. I have to find out the mu of the surface. Mu of air is given as 1. So can I apply Snell's law out here? If I apply Snell's law out here, this is nothing but the critical angle, theta c. Okay, and this angle can be found out using this triangle. This angle is equals to this angle is equals to theta c. Okay, theta c. Can I say tan theta c is equals to 3 by 4? If this is 4, this is 3, this is 4 square plus 3 square under root, and 4 square plus 3 square under root is nothing but 5. 4 square plus 3 square is under root is nothing but 16 plus 9, 25, under root is nothing but 5. So this length is nothing but 5 by Pythagoras theorem. Okay, so from this triangle
Can I say sine theta is equals to perpendicular by hypotenuse, or sine theta is equals to 3 by 5? Okay. So applying Snell's law out here. I'm applying Snell's law out here. Mu of water into sine theta c is equals to mu of air, which is equals to 1 into sine 90. Sine 90. 1. Or mu of theta c is nothing but 3 by 5. 3 by 5. You have to find it out. Mu of air is not 3 by 5. Mu of air is mu of water is mu only. Sine theta c is nothing but 3 by 5. Sine theta c is 3 by 5 is equals to 1, or mu is equals to 5 by 3. Now we know that refractive index is nothing but velocity of light in vacuum, velocity of light in vacuum, which is nothing but 3 into 10 to the power 8 meter per second divided by velocity of light in that medium. Velocity of light in medium. Okay, and this portion is asked, and mu out here is given as how much? 5 by 3. So if you cross multiply, velocity of light in medium is equals to 3 into 10 to the power 8 divided by 5 by 3 divided by 5 by 3, or into 3 by 5, or velocity of medium is equals to 3 into 10 to the power 8 into 3 by 5. So correct option is 9 by 5 into 10 to the power 8. Asha, what is 9 by 5? Let's see. 5 divided by 9. 1, 5, 4.8. So 1.8 into 10 to the power 8 meter per second. 1.8 into 10 to the power 8 meter per second. Our correct option is option number A. So, let's read this question. A air bubble in a glass slab with refractive index 1.5 near normal is 5 cm deep when viewed from one surface and 3 cm deep when viewed from the opposite face. The thickness of the slab is. That means what is the question saying? The question is saying there is a glass slab, okay, and there is an air bubble inside the slab. Okay. When an observer is looking out here, the image appears to be 5 cm deep. So for this surface, or for plane surface 1, okay, for surface 1, okay, can I say V by U is equals to mu R by mu I? So if the bubble is out here, the incident ray is inside the slab, no, of mu is equals to 1.5. So incident ray or refractive index of medium constant by the incident ray is 1.5. Refraction happens out here and the ray reaches out here. So refracted ray is out here. So mu R is nothing but 1. The image appears to be 5 centimeter deep. So this is 5 centimeter. So can I say U is equals to 5 into 1.5, or is equals to 7.5 centimeter. Okay, so the actual depth of this bubble is 7.5 centimeter from this surface. Now from surface 2, or this surface, okay, observer is seeing this bubble, and he is observing 3 centimeter. That means from surface 2, can I apply the same formula for curved surface? V by U is equals to mu R by mu I, where mu R is equals to 1, mu I is equals to 1.5, V out here is equals to 3, and U is nothing but U is equals to 1.5 into 3 is nothing but 4.5 centimeter. So actual U out here is 4.5 centimeter from the surface. Okay, this formula came from refraction through a cut surface where radius is equals to infinity. Check that slide. Okay, so the total width of the slab is 7.5 plus 4.5. So 7.5 plus 4.5 is nothing but 0, 1, 12. The correct option is option number C. Okay, this is the same type of question. A transparent cube contains a small air bubble. It is its apparent distance. That means the image or the perceived distance is 2 centimeter when seen from one face and 5 centimeter when seen to the other face. That means there is a cube. From one face, the apparent distance is 2 centimeter. So from the first surface we apply P by U is equals to mu R by mu I. And mu I is 1, mu I is 1.5 given in the question. See, 1.5 is given in the question. Okay, V is given as 2 centimeter or image or apparent. Okay, so U out here is equal to 3 centimeter. So the bubble is 3 centimeter from this surface, and when I'm looking through this surface, okay, for surface 2, V by U is equals to mu R by mu I. This formula came from a formula for curved surface. When you put R is equals to infinity, out here even mu I is equals to 1.5, mu R is equals to 1. The perceived distance is nothing but 5, or U is equals to, how much? 5 into 1.5 is equals to 7.5 centimeter. So from out here it is 7.5 centimeter. So the total distance is 7.5 plus 3 is nothing but 10.5 centimeters. Okay, let's read this question. Light travels through a glass plate of thickness T and refractive index mu. Let's see the speed of light in vacuum. The time taken by the light to travel across thickness of the glass is. Okay, this is a glass. The thickness of the glass is T. Okay, and speed of light, if this is mu, okay, speed of light in vacuum, mu is nothing but speed of light in vacuum divided by speed of light in medium, okay, or velocity of light in medium is equals to C divided by refractive index of the medium. Okay, now to cover the thickness T, how much time did the light take? The light took around, or this is 1, this is 2. Velocity is equals to distance by time, or time is equals to distance by velocity. But distance is equals to T, velocity is nothing but speed of light by mu, or time taken. Time taken is nothing but T divided by C by mu. This mu goes upward, and time taken is equals to T into mu by C. T into C by T into mu by C. Option number D. Okay.